Alrighty, we are at 11.6, 11.7 surface area of pyramids and cones. We're going to get this into 2 days. We'll do volume another day, but today we're going to do surface area for these two things. Here comes some definitions. Probably want to copy these down. A pyramid is a polyhedron in which base is a polygon and the lateral faces are triangles with common vertex. We'll break down some of this vocabulary a little later. Lateral faces are always triangles in the pyramid. And you notice there's even triangles in these pyramids, right? Like this. Those are lateral faces. How do you classify these pyramids? You are going to use the shape of the base. And we're going to look at that in an example on the next page here. What is a regular pyramid? And this is what we're going to be using for the most part in our problems here. The base is a regular polygon and height goes to the center of the base. So that's kind of important. Good to write the definition of regular pyramid down. One more thing that is good to note, and you have this in your notes, maybe highlight it, the slant height is what we're typically going to either mix up or we really need to make sure that we know where this is coming from. Of a pyramid is the height of a lateral face. And so you'll see where this is located down here. Before I start talking about some of those different components, don't worry about oblique pyramids. We won't talk about it as much. That's what it looks like, but we'll work with right pyramids for the most part. All right, first things first is the base. What is the base? What is it talking about up there? The base is going to be this bottom shape, okay? This rectangle down here. And that's what most of the Egyptians created, right? In those pyramids, they're rectangular pyramids. Now over here, looks like the base is a triangle. So we'd call this a triangular pyramid, right? A triangular oblique pyramid. But we're going to work with these ones on the left here. All right. So that would be the bases. The bases is like that bottom part, okay? And it's the shape. The lateral edge, okay, is something that's good to note, but we're not going to typically find it as much in our problems. They go from the top to one of the corners of your polygon at the bottom, one of your corners of your bases, okay, of your base. Now, are you going to use this much? No, what you're typically going to be finding is this slant height. So a lot of people mix up what's the difference between lateral edges and slant height. You want to know what this is. And we're going to represent this later with a lowercase l. Okay, it goes from the top of the pyramid, the vertex, okay, and it's going to go to one of these, it's going to go to the middle of one of the sides of the base edges, okay? And if you notice down there, it creates a right angle as well. So that's what its kind of definition is. It goes from the vertex to a side of the base to where it creates a right angle, okay? And so that's what we're going to use in our formula, this lowercase l. We are not really going to use this lateral edge as much, okay? So good to know what slant height is. Okay, and you will apply this to triangular ones too. And the last thing is height. Okay, and that's pretty straightforward. It goes from the top to the middle of the polygon. That's creating the pyramid, and that's about it. And so it also creates this right angle, which means that we're going to have a right triangle. Okay, and so we're going to see that in our next problem. Let's take a look at how we're going to find slant height. All right, find the slant height of the pyramid below. All right, so looks like they give us the height, that blue line is 100. Okay, they also give us this green line. Right, see this? Okay, now that green line's not 200. If you remember what I said before, this height comes right down into the middle, which means that if this whole thing, didn't mean to do that. If this whole side is 200, that means that from here to here must be half of it, just like this. So if that's half, shouldn't that also be 100? Great. And what they want to know is this red line, right? They want to know what that red line is, the slant height. If you even needed to, you could put a right angle there. Remember that it's not this other part from here to here. Okay, that goes from a corner to the top. We don't want that. That's the lateral edge. That was in the orange before. We don't want that. We want the red, that red line. Okay, so they give us the blue line, which is 100. Okay, and I can represent that red, green, blue line over here on this side. Okay, so the blue line was 100. The green line was 100, right? Not 200. Remember, we cut it in half because it's half of that whole thing, right? And then, well, we don't know what the red line is. Oh man, we can find out. You know what this is. We're going to use the Pythagorean theorem. 100 squared a squared plus b squared, 100 squared, equals c squared, that red line. Great. Looks like we have 10,000 plus 10,000 equals c squared. That means it's 20,000 equals c squared. And to get rid of a square, we take the square root, both sides. Nice. All right, here we go. Type that in the calculator, you get about 141 and 42 hundredths. Looks like we're in feet, so we're going to use feet. And remember, this is just a side, so we don't need squared or cubed or anything like that. Great. And that's going to be our slant height. L equals this stuff. Bonus points. If you know what this kind of triangle is, it's a special triangle, I'd give you candy, but I don't have candy. I have virtual compliments though. Okay, if this was a right angle, right? And we have a 100 here and 100 here, that means we have a 45, 45, 90. X rad 2. So isn't this 100 rad 2? If you typed 100 rad 2 into your calculator, hey, you get this. You get the same thing. So you could have done this a little bit faster if you knew your special triangles. If you didn't, man, just use the Pythagorean theorem. You'll be squared away that way. But yeah, there we go. We found the slant height. Okay, and that's going to be an important factor into our formula for the surface area of these things. So let's take a look at surface area. Here we go. Here's the magic formula. Now, unlike other formulas that we've used before, this has a little bit more to it because it has these capital letters involved. And we need to really define what these capital letters mean. S, well, that's just the surface area. Some people even use SA. You don't have to, but it's something that you could see a little bit later. But good to know. S is going to be that surface area, so our answer. Okay, big B, and I mentioned this before, big B is the area of the base. Now our base could be different shapes. We talked about that before. We had a base that was a rectangle. That's what the ancient Egyptians used, right? Rectangular bases to build their pyramids. Rectangle. Okay. If you wanted to find the area of a rectangle, the area of that base, right, you'd use length times width, or base times height. Now, a lot of our problems are just going to be squares, so it's going to be just s squared. But if you just want to be technical with a rectangle, you could just use base times height. Now, be careful. Do not use the height of your pyramid. Here's what I'm talking about. If I had a rectangular pyramid, right, it'd be like base times height down here. What I'm not saying is that when you finish your pyramid, right, you're not going to be using this height in that little problem there, right, where it goes to the center. Okay, I'm just talking about base times height, right, to find, use the blue again, we're finding this area, just like we did with 2D shapes. If you wanted to find this area, right, it's base times height. So just want to be clear on that. And 2, we've also said that the area of the base could also be not just a rectangle, but a triangle. These are the main two we'll be using for these pyramids and cones here. Or, well, pyramids, really. Right? And so if you want to find the area of a triangle, a triangular base, right? So if you had something like this, right, you're finding the area of this stuff. Okay, you need to do base times height divided by 2, right? The area of a triangle is base times height divided by 2, where the height, right, is, there's that mouse of mine. Oh, I saw it. Oh, it's roaming around. There we go. This is the height, and this is the base down here, right? Okay, we've done that before. I just don't want to mix it up with, like I said before, this part up here. We're not using that. Okay, we're using the height of the triangle as the base. All right, very good. That's probably the most confusing of the mix. Okay, so just be careful of knowing where the base is. It's very important that I highlighted that. The rest of it, okay, is going to be the perimeter. Okay, so P is the perimeter of the base. So if, let's just say, this was 2. Whoa, I don't want to use that. Let's just say this was 2. Man, really mixing up these things. This is 2, this is 2, this is 2. 2 plus 2 plus 2 equals 6. So that would be my perimeter, right, of that base. Okay, not adding up every single side of everything they give you. Okay, it's just the area of the base. Okay, so I'll give you another example. This was 3, this was 3, this was 3, this was 3. Okay, I do 3 plus 3 plus 3 plus 3, which is 12. Okay, that's the perimeter that we're talking about. Okay, last thing, we just found this kind of stuff, is a slant height. Okay, and that's where you might use Pythagorean theorem and different things like that. But the most important part is knowing where it is, where it goes from the top to one of the sides and creates a right angle. It's not one of those lateral edges. We talked about that. This formula derives from when we take the base, okay, get that, and then we're going to add, okay, 1/2 times the slant height times the perimeter, this stuff. Ooh, I don't know why that happened. Okay, and take that. This stuff is going to be, when we create those final parts, the lateral edges are then added to the base. So all this stuff I'm highlighting is the lateral edges, okay, which is represented by this part of the equation. So we're going to add the blue plus the green, and that's what we're doing. That's how this formula kind of comes to be. All right, so let's try to find the surface area for a triangular pyramid here. Here comes surface area for the following pyramid. Okay, this one's going to be the trickiest of the bunch because there's quite a few formulas we're going to have to use. Notice we don't have a rectangular pyramid anymore. We have a triangular pyramid. Okay, so let's label some things we have. Okay, well, we have 15, 15, and 15, right? So we can find the perimeter pretty quickly. We just do 15 plus 15 plus 15 and get 45. That would be the perimeter of our base, right? Of our base, okay? Our slant height, oh, they give us that. Look at that. It creates that right angle. It goes to the middle of that, goes through the middle of that lateral side, right? Not the lateral edge, it's the slant height, right? 9. Typically, you're going to have to find that, but they give us that in this problem. That's awesome. All right, what else do we need? Let's see. That's a lot of these formulas. You got to see what you need and then go find it. Okay, we have the slant height. We have the perimeter. We don't have the area of the base. We said of it when we have a triangle, the area of the base is a triangle. Big B is a triangle base. Okay, we're going to use base times height divided by 2. So let's go ahead and look at our problem again. Now, sometimes it might be even helpful to redraw the triangle as a two-dimensional figure. You know what I mean? Just do this, right? Say this is 15, this is 15, this is 15. This is the area you're going to find. You want to find the area of this shape, okay? Well, the base is 15. We said base times height divided by 2 is going to get us the area, okay? Well, the base is 15, and we know the height is going to be this thing right here. Well, if I'm creating a line directly down of an equilateral triangle, okay, equilateral meaning, right, all the sides are the same. If I'm going to cut this in right down the middle of this kind of shape, that means that this is going to be 7.5, right? It's going to be 15 divided by 2. This is 7.5. Uh-oh, look at that. I know that's a right angle, right? Looks like I can use Pythagorean theorem. Hey! And that's going to get us the h, which is then going to finish the formula, and then we can punch it into the final surface area formula. Okay, so let's go find h. So we have h squared, or you can do a squared, that's fine, plus 7.5 squared, right? Base times height, or sorry, a squared plus b squared equals c squared, right? C squared is that hypotenuse, right? C, that goes on this side, so 15 squared. Whew. All right, let's do it. Once you subtract both sides by each other, 7.5 squared, subtract that from the 15 squared. Let's see what you get. I got 168.75. Now you take the square root, okay? And you know what? I would just, for the sake of this problem, I'll just don't even click enter on that. Just write the square root of 168.75, okay? And then divide it by 2. Okay, this is what you want to punch into your calculator. So you're going to do 15 times square root of 168.75 divided by 2. Okay, and then you get whatever that answer is. I guess, you could, there's a couple things I'm thinking, but I'll just share what this is. 15 times square root of 168.75 divided by 2. Should get about 97.43 centimeters squared, right? Because it's area. But that's not what they asked us for. They asked us for surface area. So now this is our big B. Yes. Okay. Now, I'm struggling to kind of tell you this, but I'll share this with you anyway. If you're going to get the most exact answer, you technically have to put this whole thing in as your B into your equation. Why? Is because of all those decimals you didn't include in that answer. Okay? You rounded it to 0.43. You didn't use the rest of it. That will actually drastically change your answer. It might not seem like it would, but it definitely does. So here's how you want to punch into your calculator for the final formula. And let's look at that formula that we're going to use. Big B plus 1/2 times the slant height times the perimeter. So technically, here's what you want to do. You're going to do the 15 times square root of 168.75 divided by 2. That's the big B. Okay, plus the slant height. 1/2 times the slant height times the perimeter. Okay, so plus, if you want to do 0.5 to make your life a little easier, you can do that. Then we have slant height is 9, so times 9 times 45. Oh, okay. If you do this, then you will get your total correct answer. Now, if you're kind of going with your calculator here, I'd type this in first and then add your answer from this. Okay, this you can do, okay? You punch all that in, and I'm hoping, and I'm praying that you got the same answer as I did. 299.93. And we're talking about surface area, so it's centimeters squared. Woo-wee. That was a humdinger. But that is how we're going to solve those kinds of problems. That might be one of the more involved kind of problems. So if you're a little intimidated, know that most of the problems shouldn't be as crazy. You might run into a problem like this. So just refer back to these kinds of notes and you'll be okay. All right. We haven't even talked about cones. Oh, yeah, you can skip that next one. That one's going to take us even longer to solve, so we don't need to do that one. All right. Let's talk about cones. Oh, my gosh. This has been a long video already, but no, we can do this. Cones are actually a little bit, in my opinion, a little bit quicker because you only have two different things you need. You just need the radius, and you just need the slant height. We already talked about those things. The height is going to be important, okay, because that's where we're going to use the Pythagorean theorem a little later. But sorry, let's talk about the cone. Cone has a circular base, and the height meets the base at its center. Great, just like an ice cream cone, right? This part of your equation is the circle. So you're adding the circle, and then it says that this pi r times the slant height is going to be like kind of the breading cone part of you're going to add this stuff to your whole entire area there, right? And that would be the entire surface area of the cone, okay? So that's where this kind of whole thing derives from. Let's solve an equation let's solve a problem using this formula. All right. Cool. Well, we have the radius. We have the height. Now, we don't really need the height. If you notice in our little formula, it doesn't really give us, doesn't say that height is anywhere in this, but we do need the slant height, right? We don't have it, but we do have a right angle. So that means we have a right triangle. Ooh, Pythagorean theorem. Don't count the Pythagorean theorem out. We're using it quite a bit. A squared plus b squared equals c squared. 81 plus 25 equals c squared. Add those up. You should get 106 equals c squared. Sorry, that's equals. Square root both sides. Cancel out the squares. C equals square root of 106. Why did I not put the decimal form? Like I said before, you want to use the exact value. You don't really want to round this just yet. That could change your answer a little bit later. So just use 100, the square root of 106 for now. Okay, now let's use the formula. Let's see what the formula is. Pi r squared, okay, we've seen that before. That's the area of a circle. Pi r, this looks like it's 5 squared, plus, let's look at that formula again. And this is what you do. You just look at what you need to put in the formula. Plus pi r slant height. Pi r 5 slant height. Oh man, we just found that. Square root of 106. This is what you punch into your calculator. Great. All right, once you punch all this in, this is what I got. 240.26 centimeters squared. Right? Squared because it's surface area. Right. Alrighty. That's about it for that one. Let's do this last one. Ooh, they give us some different stuff. for this one. They give us the slant height already. Do we even need to find the height? This thing? No. You don't even need to find that. My gosh. They already give us the slant height, so why do we need to do extra work? We have all the components, so let's do it. Pi r, looks like it's 8 squared, plus pi. Remember, this is just the formula from the other page, or even right here, right? Pi times r, which is 8 again, times the slant height. Oh, we know that. It's 12. That's a times symbol, a dot, right? Not a minus. Great. Punch this in the calculator. See what you get. I got 502 and 65 hundredths millimeters squared. See, these are a little bit quicker. I know that triangular pyramid was a little bit kind of much, but that, like I said, that might be a more complex one that you'll run into, where you got to find a lot of different things. Other than that, that's about it for surface